This is the homework from 10.1.4. I want you to go ahead and pause the video and check your answers. So you'll be checking your answers for the review preview section, and you're going to attach a copy of your work in Google Classroom for credit. Make sure you show all your work. If you had trouble with this, contact Mr. Punches or I. Today, we are doing 10.1.5. How much will it hold? Applications of volume, part 1. We will also be doing part 2 today. In this section, you have learned how to find the surface area and the volume of several kinds of solids: cylinders, cones, pyramids, and spheres. These skills can be very useful when solving real-world problems, such as the one that you will encounter in this lesson. You're going to use all of what you have learned, and you're going to be watching this video and taking notes and stopping the video to do some of the challenging tasks. You want to have fun with this. If we were at school, we would be working in teams of 6, and each person must participate. So I do want you to stop the video and do some of the activities that I suggest. We are going to work together through this video. Each person must record their own calculations. That means you. Topic of today's lesson is 10.62. Sam Mallory, the owner of Mallory's Ice Cream Shop, wants to be able to advertise that his cones hold the most ice cream. His cones are made out of circular waffles with a set diameter. His employees cut a wedge-shaped piece from the center and then fold it into a cone shape. He needs help determining how they can do this to create a cone with the largest volume. You have been hired to help solve the problem. As you work through the steps, you're going to neatly record your work. So your task is to use the materials that are provided in Google Classroom or the materials that I will suggest in the following video clip to create a cone of various sizes and calculate their volumes. Determine the angle of the removed sector, a wedge-shaped piece of circle that results in the largest volume. You're going to follow the steps below for creating a cone. Before you get started, you want to decide what angles you will be using to create the cones. You're going to have to do all of these yourself. So there is a handout that you could print out, or again, you can follow the directions that I'm going to give in the next video clip. So you're going to repeat the process below by using different angles until you think you have solved the task and found the largest volume possible. If you can print one of these images to participate, that would be great, but you can also draw a large circle on a piece of paper and use that, or you can use a paper plate. This is the handout that is posted online in Google Classroom. So I'm here to talk about how to utilize the props that are for this activity. So what you're going to need is you're going to need an 8-inch circle. If you can't get an 8-inch circle, any circle will do. There is a handout that you can print. This one's already been cut out, that you can cut out the circle, and you'll notice the diameter here is going to be 8 inches. And so if I were to go across, I'll confirm that this is indeed 8 inches. Let's see if you can see that. So that is 8 inches across for the diameter, going up a little. And so 8 inches, and then of course it has a radius of 4 inches. And so we're going to use this to help collect data. And if you don't have that, you can use something like a top of something that might be close to that. This one, as you can see, is a little bit less, but that's okay. And then I could trace around it and I could make a circle. And if I do that, then I'd want to take my ruler and make a plus sign to find the center, and then go ahead and go across. And then that way I can identify my radius and cut my pieces out. Another idea is to use a paper plate. And again, I could go across and I could come across this way and I could make my plus sign. Let me do that. So I'm going to go across and make a plus sign on it, try to balance it. And so when I do that, mine's a little crooked, but when I do that, then it helps me find the center of the plate. So you'll have to experiment with that. And then of course I can cut out wedges, or I go ahead and I can do 180. And if I go this way, you can break it up. So half would be 90 degrees. And then you could go halfway between that and get your 45 degrees, so that you have some sort of tool. If you have a protractor, that is great. So these are the tools that we're going to use. So I'm going to use this device, and if you're able to print it out, you'll notice that it has sort of a protractor printed on it. If you can't print it out, again, that's okay. And then, so what I can do is I can look at different measurements. So if I go on here and I go to 20 degrees, and the degrees is always after the number. So if I go to 20 degrees, then it makes a cone that kind of looks like this. And then I might want to try 40 degrees, and then there's my cone. Now they're telling you to cut the wedge out. I instead cut a line, and then I'm just sliding it for my degrees. So if I want to try 60 degrees, I go past 60, and this is what a 60-degree cone would look like, okay? And then I might want to try 80 degrees, and this is what the 80-degree cone would look like. Now, this isn't the only thing we're doing. What we're doing is, let's say I have 80 degrees, and I might want to go ahead and either paper clip that, or you could tape it, and you're going to set it on a flat surface Then what you're going to do is you're going to take your ruler, make sure that the 1 is at the bottom, and you're going to stick it on your table or whatever your flat surface is. And then you're going to take another item and put it across like this, and you're going to see how high your cone is. Then you're going to place your cone on the ruler on the side where it says 1. So I'm going to place mine right here on the table, and then you're going to read what the measurement is. And mine happens to be just about 6 and 3/4. Okay, and that was for me, that was for 80 degrees. Now I'm doing this in the air, so that's not too accurate, but you would just gently place this on here. And you want to get a bunch of measurements. You want to get the height of the cone, and you want to get the diameter of your cone. And how would you find radius from the diameter? You would divide the diameter by 2. So now we are ready to continue exploring. Now, for those of you that do not have these products or cannot do this prop, don't worry, you'll still be able to do the other part of it. And the other part of it has to do with doing this activity online, which I will walk you through. So you're not completely unable to do the activity. You still can do it. It's just nice to have the prop in hand and then try it. And you're going to be keeping a list of the numbers, and I will go over some possibilities at the end. Now that you have your prop to experiment with, you are going to follow the directions that I suggested and record your results. So when I took my paper and I measured, I got the following numbers. So for the radius of the base for 10 degrees, I actually got a diameter of 7.8 approximately, and I divided that by 2. So my radius, I'm going to say, is 3.9, and it's inches. I worked in inches. One of the things that you may want to do is work in centimeters and then convert to inches, because it might be easier for you. I know that Mr. Punches likes to do it that way. So for 20 degrees, my measurement for the radius was 7.8, so about 7, and my measurement was about 7 6/10, so 7.6, and I divided that by 2, and I got 3.8 inches. And then for my radius of the base for 40 degrees, I actually measured the diameter first, and I got a diameter of 7, and I divided that by 2, and I got 3.5 inches. Yours might not be exactly the same as mine, but it should be pretty close. For 50 degrees, my diameter ended up being 6 8/10, or 6.8. When I divided that by 2, I got 3.4 inches. And for 60 degrees, when I did that one, I got about 6.6 inches, and half of that is 3.4. Now for 70 degrees, I got a diameter of 6.4 approximately, so 4/10, and when I divided that in half, I got 3.2 inches, and this was inches. So now, as I measured the height of the cones, I got just under 1 inch. So I'm going to say it must be about 0.9 inches. I'm not sure, 0.9 or 0.8. And then when I measured the height, and the height is really tricky, I got my husband to help me do it because it's really hard to do by myself, and I got about 1.3 inches on this one, and so it was about 1 1/3 inches. And this one, it was interesting because this one I got 1.8 inches, and the next one I got, it's like it's getting taller, and so this one I actually got, it looks pretty much like it's 2 inches, pretty close. And for the next one, it went a little bit over, so I'm going to say that's about 2.2 inches. And for the last one, 70 degrees, I got a little bit taller, so I'm going to say about 2.4 inches. So now, calculating the volume, I have to use this formula. So let's set these up. So for the first one, the volume is going to be 1/3 pi times my radius, 3.9, squared, times my height of 0.9. And I absolutely do need a calculator for this. For the next one, I'm going to do that it equals 1/3 pi times, and then I'm going to do my 3.8 squared, and then I'm going to multiply it by 1.3. And that's going to give me my volume. And then for the next one, I'm going to do 1/3 times pi, and then 3.5 squared times 1.8. And volume equals 1/3 pi, and this time I have 3.4 squared times 2. Or at 60 degrees, I have volume equals 1/3 pi times, oops, there's a mistake here. This should be 3.3, and so I'm going to do 3.3 squared squared times 2.2. And then finally for 70 degrees, pi times 3.2 squared times 2.4. So the next step would be to get your calculator out and to calculate what these are. So for the first one, I'm going to enter it in my calculator, and I get, round it off to the nearest tenth, and I get 14.3 inches cubed. For the next one, I'm going to put it in my calculator, and I get about 19.7 inches cubed. So now I'm going to enter the next one, and I get approximately 23.1 inches cubed. So now I'm going to enter the next one, and it looks like it's approximately 25.1 inches cubed. And now for 60 degrees. So I get about 24.2 inches cubed. So let's do 60 degrees. And I get about 25.1 inches cubed. Notice the volume is steadily increasing. So it'll be curious what's going to happen with this one. I got 25.7 inches cubed. Now, I should go up and try 80 degrees, which I did. And what I discovered was the number started decreasing. So then what I would do is I would try 69 and then 68. And what I discovered was that somewhere in between here at about 66 degrees, I get about 25.8. And this is because I've done this before. So when you play with this, you might want to try 65 or 66 if you can model it and see if you get close to this. So we're going to actually demonstrate it using Desmos. So that will be the next part. In this tool, you get to play with the size of the diameter and the height. So as we shrink the diameter, the height of the cone gets taller. And as we increase the diameter, the height of the cone gets more shallow. Our next activity is to decide which has the greatest volume and which has the least. Before I did this activity, I thought the one with the smallest diameter had the least and the one with the greatest diameter had the most. And of course the one with the medium diameter was in the middle. Here we're going to examine what the volume is for 30 degrees. And now we look at what would the volume be for 150 degrees. And finally, let's try 210 degrees, which you notice is more than 180 degrees. So we're going to go try that one. This looks like a standard cone. Okay, we're going to put in our three relationships that we already got. You see them listed here. And then we're going to try some other ones. So as we move the little blue dot, we can try different ones. So let's try 40. And there you can see what it looks like. And you'll get to play with this. And then now I'm going to try 60. And it'll give me the volume. And finally I'm going to try 70. We can compare this to our other answers that we got manually. But you'll get to play with this. So I think the answer is between 60 and 70. So we're going to try it again. So this time I'm going to put in 60 one more time. And let's put that on our table. You can see what it looks like. And now I'm going to try 66, which I believe is the answer. And you see the volume. And then I'm going to try 70. And notice how 66, the volume for 66 is in between 60 and 70. So here's the graph. And 66 is about here. And I can go ahead and I can draw a line. It's very squiggly, my curve, to kind of give you the graph of what this looks like. And of course, right here in the center is where the 66 is. And you can see that it has the highest volume. So now there's this activity you're going to try where you're going to take your number and fill up the cone. And mine worked. And finally, this is a fun tool. Here's the graph. And as I move the point down the graph to the right and then back up to the left, I can start to see what the shape looks like. And right when I get to 66, there's my volume, 25.8. And you can see the lateral surface area of the cone. And then I'm going to drag it down to 0 and then back up to my 66, and there again you see the lateral surface. So I'm going to show you a spreadsheet which I am sharing with you so that you can play with it. You'll have to make a copy to be able to edit it, but there's a spreadsheet that shows the calculations. I'm going to go ahead and go to my desktop here, and this is our spreadsheet. So Mr. Punches likes to calculate these using centimeters cubed, so I've included it here, but I like to do it in inches since the book has inches. So what this represents is our calculations. So if we go down here and we scroll down to 20, I'm going to move this up, you will see how close we came to the calculations. And you'll notice I'm using cubic inches. So what you'll be able to do is you'll be able to open up the spreadsheet and look at how close the calculations were. I'm going to go back up to the top in just a moment, but I want to show you here between 60 and 70. If we go over 70, the number here decreases for the volume of the cone. And as we get closer and closer to 66, you'll notice it increases this way and it increases this way, and 66 degrees turns out to be the best. So I'm going to go back up to the top so that you can actually make your own copy of this. You'll just copy the one that I send you, and I put the angle measurement here. I put the original circle radius because I needed that, and you'll see the formula later about how that works. And then as I click on this, you are able to see the formula up here that I used, and as I click on the height of the cone, there's an actual formula to figure it out mathematically. And of course, here's the formula that I used to create the volume of the cone. And this would be the volume of the cone. And notice that I'm multiplying by 2.54 to the third power. That's because this is raised to the third power to change this to the volume of the cone in cubic centimeters, just in case you were interested. Now, I also put in here the calculations for the volume of a half sphere. Now, this is something different because of using different numbers. And then the volume of the ice cream scoop, and then the volume of the tub, and then how many cones filled the tub and how it changes. Okay, so as we go down to here, we see something kind of different. So this is kind of misleading, but here's the volume of the tub because this is based on a radius of 4 or a diameter of 8. And so you'll notice this is a little different than what we actually did in the lesson later on that you'll see in part 2. But you can play with this and change the numbers just as you can change the numbers here and watch how it changes. So for example, if I change this right here to, let's say, the 2 or 2.5, it's going to change that one, and you'll start to notice that numbers change. All these numbers here are going to change. Okay, so I'm going to put this back to a 4, and then we'll save it as that. I just wanted you to know that this tool was here and that you can make a copy of it and play with it. Here are 2 graphs created from the previous spreadsheet. Now do the review and preview before watching the next video. So I'm hoping you find today's lesson challenging but entertaining.